Next, we want to be able to write the quadratic equation or a quadratic function if we are given points of the quadratic from a graph. To me personally, the easiest way is if you know the vertex of the function and one other point on the graph of the function, it's fairly easy to find the equation in vertex form. The next easiest method is if you know what the x-intercepts or the roots of the function are and then one other point, you're going to be able to determine it. And then the hardest way is if you don't know the x-intercepts or the vertex, you can write the equation of a quadratic function from any 3 points on the graph of a quadratic function. So for the first example, what I'm going to do is I'm going to substitute the 1 and the 2 in for my h and k, and then I'm going to substitute the 3 in for the x, the -6 in for the y. Then I'm going to have an equation that only has a left for a variable, and I am going to be able to solve for a and then rewrite this in vertex form. So my first step is to just write the information I know, which is x minus 1 squared plus 2. Plus 2. That's the generic form I'm going to have. I now need to solve for a. In order to solve for a, I'm going to stick the information from the other point I know, which is at 3, -6. So I'm going to put a 3 in for x and a -6 in for y. 3 minus 1 squared plus 2. Now what I want to do is I want to solve for a. I'm going to subtract 2 from both sides. 3 minus 1 is 2. 2 squared is 4. 4 times a is 4a. Get 4a is equal to -8, or a is equal to -2. I now am going to take that -2, substitute it back up here, and my final equation in vertex form is y equals -2 times the quantity x minus 1 squared plus 2. The next easiest method is if you have the two x-intercepts. Again, I'm going to substitute 3 in for p and 8 in for q, write my generic equation, then use my third point to solve for a. So I get y equals a, x minus 3 times x minus 8. It's my generic equation. Now I want to substitute a 4 in for y and a 1 in for each of these x's. So I put a 4 in for y, and then I get 1 minus 3 times 1 minus 8. So I get 4 is equal to 1 minus 3 is -2. 1 minus 8 is -7. -2 times -7 is +14. Solving for a, I get 4/14, which simplifies to 2/7. I'm going to take this a, substitute it back in up here, and I get my final equation is y equals 2/7 times x minus 3 times x minus 8. Again, that method is fairly straightforward. Problem comes in it when I don't have my vertex or I don't have both roots. I have to substitute any 3 points from the graph of the equation. So what I have to do is I have to write y equals ax squared plus bx plus c 3 times, substituting these numbers in for x and y. So for my first equation, I'm going to write it in red. I'm going to substitute a 1 in for the x's and a 2 in for the y. So I get 2 equals a times 1 squared plus b times 1 plus c, which gives me 2 equals 1 squared is 1a plus b plus c. I do the same thing for the second one. 6 goes in for y equals a times 3 squared plus b times 3 plus c. 6 is equal to 9a plus 3b plus c. And the final equation that I'm going to get to start off with, I get 8 equals a times 5 squared plus b times 5 plus c, which means 8 is equal to 25a plus 5b plus c. What we now have is 3 equations with 3 unknowns that I have to find the solution to those 3 equations. So let me write those 3 equations with 3 unknowns. I have a plus b plus c is equal to 2. That came from this one. I have 9a plus 3b plus c is equal to 8. And that was the second one. Then I have 25a plus 5b plus c. Oops, this one should be 6, sorry. Then I have 25a plus 5b plus c is equal to 8. Just want to show you here that I now have 3 equations with 3 unknowns. I am not going to solve this. The calculators that have been checked out to you would be able to solve the system of 3 equations with 3 unknowns for you. I will just tell you the general process that you're going to want to go through. You're going to want to multiply equations by numbers so that you can start eliminating variables. So you can get down to an equation that either has just a c in it or just an a, and then you're going to end up back substituting a couple times, and you're going to be able to figure out what a, b, and c are all equal to. The whole intent of me showing you it this way is so that you can see that, yes, I'm going to be able to solve it, but it's a lot more difficult than writing the equation for the graph if you know a vertex or 2 other points on it. There will be a separate video that shows how to solve a system of 3 linear equations when we get to that section of the textbook. You will not be responsible for doing any of these until we get farther along in the textbook.